practicing with the ECT as our like warm-ups here. So we'll talk about that a little bit. Now when there's choices, that kind of helps things. So again, this probably looks really small on your paper, so I'm going to write it bigger. So this is what it should look like. We're going to talk a little bit about absolute value, because this one doesn't need to be impossible, but it's worth us discussing. What does the absolute value mean? Do you guys remember? Yeah.
The distance away from zero.
The distance away from zero. So how far something is away from zero, like on the number line. When we talk about distances, like so if I say that, like I saw you the other day running with cross country, if you ran that way 2 miles, would you consider that positive or negative?
Positive.
Positive. So when you turn around and come back, did you call that negative then? Yeah. No, because then that'd be positive 2, negative 2, you'd actually run not at all. Like that doesn't make any sense. So distances are always considered positive. So when I talk about how far something is away from zero on the number line, we're talking about it being positive. So the absolute value is technically making our outcomes positive. So it's saying a positive value, whatever this ends up being, is less than negative 1. So I need you guys to find me a value that will make this less than negative 1, a positive value. I hope some of you guys are questioning what I'm asking you to do. Can you think of a positive value that's less than negative 1? No. There are times that things, there's not an answer for them. There's no x value that could ever work that would make this work, this equation work. Now, you could also kind of use the number lines to help us. This one says it's a number in between 4 and 6. What's a number in between 4 and 6? 5. If I put 5 in here, 5 minus 5, how much is that?
0.
Is that less than negative 1?
Yeah.
No, sorry, 0 is not less than negative 1. It's okay, I know negatives and 0 are kind of like not less than negative 1. So that one doesn't work. This one, it's saying it's less than 4, so we can pick a number less than 4, like 0. But when we go to put that in here, 0 minus 5 is negative 5. The absolute value of negative 5 is saying the positive version of that. So that's 5. Is that less than negative 1? No.
I wish.
Something bigger than 6, so like 7. 7 minus 5 is 2. Is 2 less than negative 1? No, that one doesn't work. This one says either one of those. No, those don't work. We already. So the empty set means there's no answer that works because there's no positive value that will ever be less than negative 1. So having an empty number line, as strange as that is, that's a possibility as an answer. So the empty set just means nothing works. It's just kind of a fancy way to say that. But having multiple choice questions, using that to kind of test some answer isn't the worst strategy in the world. So feel free to try that when you have choices. Yeah, oh yeah, that's right. Thank you. I need to give you that. Good luck in your game. I'll be watching online. They're streaming it. All right, so I stapled it weird, but it kind of will help because there's some data that shows up on this page and that you need for this one. So just pull it apart. All right. So the first thing we're going to talk about is a frequency distribution. So what a frequency distribution is basically how many times something happens. So we're going to tally, use little tallies and write how many times that happens. So they give us this data, and it says Bev is analyzing her first 16 weeks in business. Her weekly sales are in thousands of dollars. Now they drew these little arrows just so that in case you didn't know how to read a table, here, it goes down and then back up. Like, not that that really matters. So we're going to do we're just going to do tallies here. So we're going to tally that she made 2.3 thousand, so I'm making a little mark. I'm just going to kind of keep tallying here. 4.9, so do the same here. Tallying here as I go. I probably should have drawn lines so you can see where you're at. I think separated these. It's kind of driving me crazy. I can't write straight enough. All right, so we tallied it. So the frequency chart basically says how many times that happens. This happened once, once, once. This one's twice, twice, once, 3 times. So they'll ask you to make some frequency charts as part of your homework. Stay awake, please. Now they want us to do this with group data, because right now, this isn't the most interesting data in the world here. Like, it's kind of like pretty spread out. There's a whole bunch that are just ones. So we're gonna try and group this in a way that makes sense. So, thinking about this, do you guys see any kind of so I don't know, we could do groups of like a couple thousand together. Might be a good group to do. I'm trying to think what the book did. Can't remember. So if I did like 2 to 3, and then like 4 to 5, I don't know if that's a good group. You see anything that jumps out at you? I just say maybe thousands together. So if I do like 2.0 to 2.9, will that work? And then start at like 3 to so every 1,000 gets its own group. So I'm doing each 1,000 together. Some like 9s for some reason. So I'm trying to group it so that I have more data together and we don't have it so spread out. And then I just need to do 7. When it's grouped this way, that allows us to see kind of data more in chunks than like, maybe like thinking about grades in terms of showing you guys all the grades in the class, telling you how many people got A's, how many got B's, how many got C's. That's group data. There might be a very high A and then a very low A in the same category. So how many times did I have 2 to 2.9 on here, guys? Just once. How many times 3 to 3.9? Just once. The 4 to 4.9, that's a bigger group, right? That happened 4 times, so that happened more frequently. That range of $4,000 for making that. How about the 5s? 3, 6s, 5 times, and then 7, just twice, right? So what the group data does is it kind of shows me where this is happening more frequently. So it looks like the 6s are a little bit higher, that she made $6,000 more often than she made, $3,000. So this group data is a lot nicer to look at. There's a lot less like categories that kind of helps us out a little bit. So what we're gonna do is take this group data and put it into a bar graph. So just reminding you guys what a bar graph looks like. That's the one that's a bunch of little rectangles. And being comfortable with like reading a bar graph, but also making one. So I'm gonna take this data and put it onto this bar graph. So again, when I do a bar graph though, I wanna make it so that a bar is like maybe as wide as my graph paper. It just makes it a little bit easier for me. If you don't have graph paper, you're just trying to make all the little lines equal sizes. So basically, kind of have to divide it up and try to use as much space as we can. 6, 7, 8, 9, 10. I think I could actually do, I don't know, full. So I make this the 2000s, 3, 4, 5, So this is thousands down here that she made. And then we go up the side of how many times that happened, so the frequency. If you need to get up and move, please do that. Alright, so she made 2,001 times, so the highest we need to go up is to what? What's the highest? Was it 5? The biggest number we need to go is 5. So we're going to space this in a way that makes sense. So if this is 1, 2, 3, 4, 5. I don't want to just use the very bottom of the graph, so kind of using a little bit more space on here. So in thousands, she did 2,001 time. So I'm going to color my little bar graph in there. 3,000 was at 1 as well. Sorry, I don't have my data in front of me, so you guys have to help me out. What was 3,000? Just once? 4,000? 4 times? So we're going up to the 4 this time. How many times do we do 5,000? 3. And 6. 5 times. And then 7. 2 times. Thanks. And so, oh, I didn't go far enough. And so what I was telling Ollie when I was handing him the homework, is I divided, or I put the homework, I didn't do this intentionally, but it worked well, is I only have it on the front side because some of your homework, some of the data's on one side of the other, so you're probably just gonna pull the staples apart, because I'd have to be flipping back and forth between these two to look at this. So it might be helpful to have it written out that way. Now, so this is a bar graph, so just kind of being comfortable with these names. So we have a bar graph, we've done a frequency chart already. The frequency chart's the little tallies. The next one is a line graph, but this time they want weekly sales. So I'm not just taking the same thing and making a line graph with it. What that means is I want to show each week as a data point. So like week 1 is going to be down to here, 2, 3, so showing every week. I believe it said 16 weeks, I think.
Yes.
And I think I gave you guys enough graph paper that it. And we're going to do sales from, basically we have to start at like 2-ish, go up to 7.2, so start at like 2.3 and get up to 7.2. Now, I didn't go up as high here, so that might mean that we have to do a little bit of figuring here. So if this is 2, 3, 4, 5, 6, ooh, this is a little bit rough. So I think I might just have to go up. If this is 1 here, if I call this 1, we're going to start with 0, 1, 2, 6, 7. We're going to have to do a little bit of approximation here in terms of about where I'm at. So these are thousands of dollars in sales. Sorry, Jamie, I'll get you this. That's pretty calculus. They're doing synthetic division right now. Those of you guys who have algebra 2 had algebra 2 here. It's like fake division.
So
It actually
it's
is.
double division, but-
You actually don't divide with synthetic division. It's kind of strange. So it's like,
multiply?
yeah, you actually multiply and add when you're doing it.
Why call it division?
Because it takes the place of division. You do it instead of division. It's weird. What do you do instead? So like instead of dividing, you multiply, and it gives you the answer of division. It's bizarre. I know. Well, that's actually something you learn in algebra 2. It's so crazy. Like it's like some weird guy found this in his basement or something.
I'm going to
So, you take all the variables out of it. Like it's kind of like, so it's no longer x's, it's all back to numbers. It's crazy. I don't know. But it's an easier way to do division.
Really?
Yeah.
I don't believe that's what.
I know, it sounds bad, but it's easier. All right, so we're gonna do this, and we're gonna go, so weekly, this is why they drew those little lines on the table, so we go down. So 2.3 was week 1. Now, like 2.3, I'm just trying to put this in the best spot I can that looks like 2.3 in my opinion, so it should be closer to 2 than 3. But once I draw this on my graph, it probably looks just like, whatever, 2.5, but, just trying to make a good estimate about where we should be. Okay, my dot's a little bit bigger here.
9.
All right. So take time to put this on our graph here. So I'm using my data in order. So I'm going down the first column. Holy cow, what are they all doing?
What did the Joker do? It's the Joker gas.
And I would guess that was Miss Miller's laugh, and she's not here, so.
The Joker gas. You're gonna listen to the letters like that.
That's, I heard Mr. Epping's laugh, but then I heard a woman's laugh, but I don't recognize that.
It sounded like Mrs. Williams.
Oh, yeah, maybe.
Why is Mr. Epping appear?
Yeah, I don't know. Who let him out of his cave?
Yeah.
Not me. Okay.
Debbie.
Debbie?
It's Debbie. Some inside joke you guys have that I'm not part of. Got it.
Dennis Willis?
All right.
Well,
Okay.
she
So-
lost money roughly.
Yeah, so now, you don't always want to connect the dots,
I'm going to connect it up.
but I would say in this case it actually makes sense to connect the dots to kind of see the trend a little bit better. Technically, I don't know if you want to say we should or shouldn't, because this is just, we don't know what point in the week she made this money, but we're going to connect them just so we can kind of see what's going on here. It kind of helps you to see the trends a little bit more. So this is a line graph. Obviously, it's a line, so line graph. It shows us the trend. Is she trending upward? Is she doing better? Does it look like
Yes.
Yeah, it seems like things are going okay. There's a few dips in there, and maybe there's things that cause that to happen. We don't really
Maybe
know.
She bought some new product.
Yeah. Or maybe having good weather helps her business, or having, bad weather, whatever it happens to be. If she's a coffee place, maybe bad, the warmer it is, it's worse. So, it kind of depends on the situation.
Well, still Starbucks is going up. It doesn't matter.
So it says her break-even point is about $5,800 per week in sales. Estimate how many weeks her business lost money. How would you decide that? What are you looking for? Yep.
You're gonna make a flat line at
Very-
roughly $5,800 and see all the points that are below that.
Yeah, so actually that's really good. So he's saying let's make a flat line, add about 5,800 and check to see
Remember
when
that-
are we,
I think normally that you'd be that break even point would be your 0 line, and you'd go up from there.
yeah, so, yeah.
Where do we pull 5.8 on?
Oh,
E.
because that's, sorry, he was working a little bit ahead. So the next question said her 5,800 per week, and 5.8 is how it translates to be thousands. Good question, thanks for asking. But, so we drew a line there, and the line I think is really visually, like if she she was trying to convince like investors or something to be part of our company. It's really, it's like easier to see now where it's good and where it's not so good. And again, we're trending upward where the first few weeks, like building our business, like it becoming popular, whatever it happens to be, and then now it seems like we're headed in a good direction. So all the ones that are above, we can include those as positive. The ones where she lost money were all the ones below. And did you guys count them? How many was that?
I counted 8.
You guys counted. You counted 8. Did anyone else count?
Yeah,
8?
it is a.
Yeah. So about 8 weeks. But a line graph is a really nice way to look at that. Now you might say, I just look at the table. But if you're in a meeting with a bunch of investors or something and you had a chart up like this, and again, I would probably like have her argue for the fact that things are trending upward, that it looks like she's headed towards the point where hopefully there's big, he said maybe she's too risky because she's got big dips, but maybe she has explanations for those, who knows. So line chart. So far we've learned 3 different types of graphs: frequency, bar graphs, line graphs. So we should be comfortable with using those, reading those. The next one is probably the most like toughest to make, and that's a pie chart. And the reason why, because if you make a good pie chart, you shouldn't just draw like your pies, your slices of pie however you want. So I'm gonna give you guys a gift. This is a really big gift. All right, so it's actually a little protractor. Now, it would be easier if you have your own protractor. You can feel free to use that. I don't know if you really carry that around. That'd be extra on your part. But what would be best though is if you actually cut it out, and even better is if you cut the center out. And you could probably even just cut like the little, like U shape. Really, you only need like the outside part. But I'll pass these out and then pass some scissors around. These are Miss Miller's scissors, so let's make sure she gets them back.